I'm not.
I'm not.
It's gonna be.
I'm excited, but it quite possibly will be.
Our choir's not
Uh-oh.
ready. No.
I hear from Clara.
Huh?
I mean, it's just
Just true.
Okay.
What was it?
So, today what we're going to do is we are going to do 10-2 and 10-3 together. Okay, because 10-2 is graphing square root functions, 10-3 is graphing cube root functions. We're just going to do two functions one day. We've already done translations. This will be a piece of cake. We got it. Okay, so notice that they give this to us in, I hope this looks familiar to you.
No.
Okay, so that's the vertex form, right? Okay, so we're working within this vertex form. The only thing that's different today is I'm including a new function. Okay, so the square root function, and then we're going to talk about the cube root function. So we need to know exactly what these look like. You did graph them in the last assignment, so this shouldn't be a shocker by any means. Let's talk about the parent function of just the square root of x. Okay, so parent function. Okay, so we're going to do the square root of x. So who can tell me what the square root of x looks like? If you must. What did you draw yesterday when you were drawing the square roots? They were like, yeah, they were like parabolas that were turned on their sides, but you only drawed one half of it. Okay, so we can say that the vertex hits right at 0, 0, right? Okay, the slope of this would be up 1 over 1. Okay, so it's going to cross right through the point 1, 1, and it's going to curl and go up and to the right. Okay, so it's basically not a I keep trying to say John Travolta, a parabola. It's a parabola that's on its side, but only one arm of that. Okay, so all we're going to do is translate that function. We haven't even done anything yet.
No, I was. The tablet was not working.
Oh,
It
technology.
like was on the homework and not on the actual.
Okay. So all we're going to do is take, this looks like a good one. Number 1. Okay, so all we're doing is graphing this. So can you tell me what the two translations are? Okay, good. So this is going to go down 2. It's going to go to the right 3. And then what is that 2 that's out in front going to do? It's the slope, okay? So technically we would call that a vertical stretch. Okay, so there's a vertical stretch. Okay, but we can still be thinking that this has this idea of a slope of 2. Okay, so if we go to graph this, what is my vertex going to be? Okay, good. So it'll go to the right 2 and down 3. So we're hitting exactly at the point 3, negative 2. Okay. Now all I need for the square root functions is just one other point. Okay, since we only have one arm of our function. Okay, so I'm going to use the slope to come up with the second point. How would I move from my vertex? What's the slope? So what's my movement? Say that the other way around. Nope, say that the other way. Up
Over
to,
one, up to.
over 1. There you go. Up to, over 1. Okay, so it's going to land right here at this point, which is going to be 4, 0. Okay, so it's going to go up and to the right. So can you envision this? Up and to the right, that parabola. What do you think?
Wait, wouldn't it be
Like a parabola?
the side?
No, because we're dealing with a square root. Okay, so a square root function is always going to be turned on its side.
Okay. This isn't actually
Technically, it is the inverse of a quadratic, yes. So are we okay with that one? Shall we do another?
Let's do.
Can you wait
Yeah.
till I'm done with notes? This shouldn't take too long. All right, number 2. Okay, so for number 2, first, what are the translations that you see? Ooh, okay, so I heard up 1, and I heard right 2. Okay, what else happens? What does the 1/2 on the inside do? Good, horizontal. Which one is it? A stretch or compression? Stretch. It's always opposite when it's horizontal. It's like you're think opposite. Horizontal stretch. Okay, and what does the negative on the inside do? Well, it like physically does something to the graph. What does it do? What? I think you said it, but I couldn't hear it. You kind of got quiet all of a sudden.
Okay, so instead of like going up that way, we come down.
Close. You're really close. It doesn't curve down because that would be a reflection over the what causes something to go upside down? Over the x-axis. Okay, so if it doesn't reflect over the x-axis, which axis might it reflect over? The y. Okay, so remember, negatives on the inside reflect over the y-axis. Okay, so this reflects, whoops, over y-axis. Okay, so if we go to graph this, where's my not my translation? Where's my vertex gonna land? Right to, there we go. Okay, so we have a vertex at the point 2, 1. I'm going to label that. Okay, so now I have to figure out how this is going to work. Okay, so if it's going to reflect over the y-axis, what is it going to look like? Do you see it? Okay, so normally it goes up and to the right, but if you reflect that over the y-axis, it's going to go up and to the left. Okay, so when I'm working with the slope and I'm dealing with horizontal stretches and compressions, I think that it is easiest to just pick an x value to find a second point. Okay, so what would be a super easy x value that this function is going to cross through that goes to the right that we can plug into the equation? 0. Okay, let's try 0. Okay, because it's going to go up and to the right. So if I plug in 0, it's 0 minus 2. What's negative 2 times negative 1/2? 1. What's the square root of 1? 1. You would be surprised at how many people think the square root of 1 is the square root of 1. So 1 plus 1 is 2. So what was the point we just found? 0, 2. Okay, so there's my second point. See that vertical stretch that just pulls this function? Or not vertical, I said vertical. I mean horizontal. Okay, everybody okay with that one? That's pretty much as complicated as they get with those horizontal stretches or compressions. Do I need to do another example of graphing these? Ready for cubics? Okay. Cube roots. Okay, so moving on to cube roots, we need to know what the parent function looks like first. Okay, so the parent function, which is the cube root of x, looks like, anyone? John Travolta, and specifically, how is John Travolta positioned? Sideways, right? He's like laying on the ground. I don't know why. We can make up a story.
He's flying.
Oh, he's flying. Absolutely. Disco dancing and flying at the same time, naturally.
Naturally.
Okay, so we can all say the vertex is going to be 0, 0, right? Okay. What's the slope of this John Travolta? 1. So we can still go up 1 over 1. And we can go down 1 over 1. Okay, and he's going to have kind of this, I don't know really now if that's his right arm or his left arm, but
Well, if he's laying this way.
it depends on if he's looking at you or
Then,
if he's going this way.
yeah.
But or is he going this way?
No, he's going this
He's Superman. Oh, he is Superman.
Yeah.
He became a Superman. Perfect.
John Travolta's now Superman.
He's super Travolta.
Super Travolta.
Okay, example.
It's so natural I could do it with my eyes closed. That was the joke of the day for students.
All right. So, translations.
Whoa. I don't like it.
Up 5. What else? Right 3. Okay, good. The 2 makes a vertical stretch. Okay, which by the way, we can be thinking about a slope of 2. Okay. So where's my vertex going to land for this super Travolta? Really like that. To the right 3 and up 5. Is that what everybody's sketching silently? So 3, 5. Okay, now on a Travolta, I need 2 additional points. So how can I come up with 2 additional points? Okay, so using the slope of 2, so from there I'm going to go what directions? Okay, I can go down to into the left one and get that lower one. So would we agree that that point is at 2, 3? And then to get the other one, we'd go up 2 into the right one. So that point lands at 4, 7. Okay, so can you envision the way he's laying?
No.
John Travolta's are a little bit hard to envision.
It's hard if you need a vision.
Yeah, it takes a little bit of practice. So if you have to graph it in the calculator to help you draw the wiggle,
Draw the wiggle.
you can do that.
Do the wiggle.
Doesn't work that way.
What's that? Wondering how I got 2, 3? From the slope. So since the slope is 2, right?
Yeah, so you go.
To get this other arm, I know I have to go have a negative slope, so I go down 2. Okay, do I need to do a more complicated one with a John Travolta? One more? You feel like you got it? Well, you'll figure it out when you get there. You'll ask me if you're stuck. So we're good? Okay.